The panel will be moderated by Noor Saif Mazrouei, Head of the AI Program at Trends Research and Advisory. Please join me in welcoming Noor and our distinguished speakers.
Good morning, everybody, and welcome. In this session, we're going to explore how technology and AI can help shape the future of water sustainability. Please allow me to introduce our outstanding panel of experts. Professor Saeed Alkhazraji, Professor of Chemical Engineering at Khalifa University and founder of the UAE water startup Manhat. Professor Philip Hart, Chief Researcher at the Renewable and Sustainable Energy Research Center, TII. Alya Mazrouei, Director of the UAE Research Program for Rain Enhancement Science and Director of Research and Weather Enhancement at the National Center of Meteorology. Dr. Hosni Ghedira, Professor of AI for Climate, Energy and Sustainability at Mohamed bin Zayed University of Artificial Intelligence. And finally, Dr. Khalid Ghafli, Assistant Professor at the College of Engineering, UAE University. It's an honor to have so many experts gathered in one room, and I'm looking forward to hearing from you all. To begin, I'd like to invite each of our panelists to share their remarks, and if time permits, we can then open the floor for some questions. So let's begin with Professor Saeed. Professor, the floor is yours.
Assalamu alaikum. Good morning, everyone, and thank you for having me today. And first of all, I would like to say a few things about the journey we took through our startup Manhat and how global the water problem is. If I mention that water issues are in places where usually we don't associate water stress with these countries. One of them is Japan, and actually one of the reasons Manhat was selected as the Best Practice Awards in the Japan pavilion, currently in the Japan Expo Osaka 2025. One of the reasons we were selected is that there are islands in Japan where they have water challenges. I'm not saying about the availability of water, but the contamination or the possibility of having more water to sustain specific standard of living. Not only that, also we have been, we talked to colleagues in Vietnam where they were looking at our technology to see how they can adapt our technology to help Vietnam farmers. And the first thing that came to my mind, I said to them, how come Vietnam has water issues? They are literally drowning in a lot of water, not only from the rivers that comes from the Himalaya, but also they have a good, rainy seasons that allow them to sustain farming for as long as they can. And the answer came very shocking to me in the form of, yes, they do have a lot of water, but it's actually not what it used to be. The challenges when it comes to water from rivers is highlighted by the excess damming upstream, where they don't receive the same amount of water that they used to. And that caused problems for farmers in the delta because seawater starts to penetrate all these underground water, and their water salinity starts to go up slowly. The third example I'm going to mention is Mexico. We actually were in Mexico in June, and we talked to business leaders there and government employees in different states in Mexico. And each state has different challenge. Some states are dry. Some states have a lot of water, but it's contaminated because of industrial activities. So my point from, the starting point for our discussion is that don't think that water is only localized or in the areas where our traditionally don't have access to fresh water. It's a global issue. And I'm going to mention one thing. If you look at any body of water globally, chances are it's contaminated, especially if it's close to human activities. whether we like it or not, somehow we find ways to contaminate the water that we actually use. And I can be proven wrong. Yes, there are instances where water quality remains the same in many different rivers and lakes, but the general observation that we tend to spoil and pollute the water resources that we touch. Which means for sustaining industries, we must always purify the water around us. Whether out of necessity because we don't have water, especially in arid regions, or because some water bodies have been contaminated. So having this general introduction, I would like to say that one of the key challenges when it comes to water is the value of water, the cost of water itself. If you look at the current best plants globally, people say we already reach $0.50 per cubic meter cost, maybe $1. That's the average. That's the average for a cost of water that we produce. If you use the same number and you multiply it by the amount of water we actually use globally, then that's at least $10 trillion of value of water that we actually don't pay for because nature provides all the time. But because we contaminate a lot of our natural resources, then everybody will start to pay for the water that they use, directly or indirectly. So the question then, first of all, what are the methods to produce more water to satisfy demand? Plus, how can we capitalize on innovation from universities to allow us to achieve this goal? So when it comes to water production, you have technically two ways. Either you take liquid water and you purify it, which is the standard, or you capture water from air, which is another method. So it depends on many different factors. One method will be better in a certain situation. The other is always better in other situations. But desalination through using liquid water, seawater, for example, desalination. Right now, if you ask anybody and everyone, they will say, go to reverse osmosis. Reverse osmosis is the cheapest. It basically comes from the simple fact that if you want to produce water and you have the energy to do it, to maximize your energy is to use reverse osmosis. In another way, if I have 1 kilowatt of energy, reverse osmosis will give you the maximum amount of water you can produce, right? So that's why reverse osmosis is the best. But it comes with a caveat. One of the issues with the reverse osmosis is the brine production. And this brine actually goes back to the ocean. And statistically speaking, we are producing more brine than fresh water. Okay, so that's a fact for today, I guess. So one of the issues with reverse osmosis is that we have to deal with the brine. Brine actually is rich with a lot of minerals. You can use it for different applications. But so far, there's no large-scale, utilization of brine. The second issue is you always need energy to produce water, which means either you burn fossil fuel or nuclear energy or solar, because energy in this sense is electricity, and electricity is invented 200 years ago, right? It made our life easier, but it complicates our life as well. So the question is, can we decouple production of water from electricity? And that is one of the theme of research we are doing at Khalifa University. In a sense, can we produce water without using electricity? And the answer is yes, but the quantities and the research required to allow us to compete with other technologies is still in its infancy. So going back to research at the universities, what we have been doing at Khalifa is we tackle different themes when it comes to water production. A lot of the challenges with the reverse osmosis always come back to the membrane. So there's a wealth of research in the water center at Khalifa University, where we focus on improving the membrane technology to allow us to produce better water quality. The second thing, we develop materials to allow us to use them for wastewater treatment. It's the easiest, way to produce water. And recently, we use AI as a tool to actually predict performance of membranes or design materials to allow us to produce better water and higher efficiency when it comes to water purification. But overall, the main objective of all research at universities is to take it to the market. So that is where we have to collaborate with ecosystem players to take these technologies from its infancy to the market through different organizations. So that's, in general, what we think about the intersection of technology and water and what we believe we can do together. Thank you.
Thank you, Professor Saeed, for an excellent start to our dialogue. And now I'd like to invite Professor Philip Hart to share his insights.
Okay. How do I follow that? Good job. So I've been working in technology development for many years, and what's striking about the current period that we're in is the speed of technological change, right? Which far outstrips really our ability to implement at scale. And I guess one of the best demonstrations of that, and one of the biggest disruptors right across the water sector, but in almost every other sector, is AI. Because it enables us to crunch huge data sets to understand what's going on in almost real time and to be able to optimize systems in almost real time if we implement that type of system. But there is a certain amount of hype, though. AI is not the cure for all ills, right? It's absolutely not the case. What it is a taker of data and a thing that can make sense of that data and allow us or it to make better decisions based on that data, which can lead to huge energy efficiencies and production efficiencies and things like that. But it's important to recognize that it's not a thing that does anything on its own. It informs things that can do stuff. So it informs an automation system, or it informs a human so that they can then take action. How it does that is by looking at historical data and saying, okay, based on that data, this would be the best outcome. And it repeats that during the training mechanism millions of times to try and optimize the decision that it's trying to advise to do. Now that's brilliant, as long as you're implementing onto a system that is only seeing those things that it's been trained on. And one of the biggest risks associated with AI, when you start to talk about handing over control potentially of really critical infrastructure, is what happens if something unexpected happens, and how does the AI system respond to that? So there's huge potential benefits from AI, but there are concurrent risks that we need to be aware of. So if we think about AI in water, what could it do for us? Well, essentially you could implement AI anywhere that you're gathering data, and you can use that to optimize and make very fast, very accurate decisions. So if you think, take it all the way back to, well, how much water do I need next Tuesday between 2 and 4 o'clock, all right? At the moment, we're forecasting that. We're, as humans, trending historical data and saying, okay, I need to procure this much water for that period of time. But AI can layer on top things like, okay, but I know there's a huge conference going to happen in Abu Dhabi downtown. Or I know that the weather is going to be particularly hot, therefore I'm going to use more water and stuff like that. And what it can do is take inputs, it can make weather forecasts, it can look at utilization patterns, and run hundreds of scenarios per second, whatever, to say, okay, I can make a much better and more accurate forecast for what I'm going to need. If you look at the impact on, for instance, a desalination plant, what we do at the moment is we set what we think are the optimal operating parameters for that plant. We hit the button and off it goes. But what happens in a desal plant is membranes will become more or less efficient over time. The pressure that you need will change over time. The input quality of the water will change over time. The cleaning cycles, when we last did maintenance and all that. All of that says that optimal operating point that we just sit and select and press the button and say go, that is on average the best optimization that we can do. What we can do with a system that can monitor thousands of points every second and look at those operating regimes, look at the input water quality, look at the last time that we changed the membranes, look at the last time that we cleaned. A system that can look at that and vary the operating parameters of every single segment of the plant can obviously then lead to a more efficient plant. So you can output more water for less energy, less pressure and all of that sort of stuff. And it's been shown, at least theoretically, that you can make huge improvements in efficiency just by doing that. So once you've reduced your water, you then got to distribute and get it to people who want to use it. Right? AI can influence that as well, because if we put enough monitoring places around a water network, we can go, all right, we're producing X million gallons and putting that onto the network. We're using this much. Okay, hold on, there's a mismatch there, so we must have a leak somewhere. And if we have enough sensors around the place and we understand the network well enough and we can process that data quickly enough, we can start to use AI to identify where the leak is within that system, if you have the data flowing in. And that's one of the key challenges at the moment of, can we monitor enough points on the network to be able to do that? It can also look at how each individual component in your system is working. And there's this thing called adaptive predictive maintenance, where if we just think of a pump, just isolate a pump for a second. We know that, for instance, for a certain amount of energy put into the water, that pump should draw a certain amount of kilowatts. We know the acoustics of that pump when it's operating correctly. We know how much vibration is normally happening from that pump. The world of predictive maintenance uses AI to sit there and go, okay, is that pump operating exactly how I expect it? Is it demanding the right energy? Is it making the right noise? Is it vibrating at the right frequencies and stuff like that? If you monitor that quickly enough, and you monitor every one of those pumps on the network, and this is something that AI is brilliantly suited for, we can start to look at, oh, the vibration on that pump's starting to change. Something may be going on there, and I may want to schedule maintenance onto that. It may be able to look back and say, last time I saw that change in vibration characteristics, that pump lasted 6 months and then it failed completely. So I can schedule maintenance for maybe 5 months' time, based on all of the learning that I've done from all of the pumps on the system. So you can start to move away from scheduled maintenance, where you say, I will do maintenance on that pump every 6 months, to just going, I'm just going to monitor that pump, and I'm going to say, until something weird happens with that pump, or out of the ordinary, or until it trends past a certain limit, I'm just going to leave it alone. And that reduces the maintenance requirements on huge water networks quite dramatically. And there's indications that if you can do that, you could maybe halve the amount of maintenance that you need. And that comes with obvious cost savings and all of that sort of stuff. The challenge with all of that is if you think that AI is the answer to everything. It's clearly not. And there we start to expose the risks of what we're doing. So let's say that pump, and it was sitting there working away nicely, and then it did something completely unusual. Right? A human being walking past that pump would say, okay, that just doesn't sound right. There's something weird going on. I need to do something, right? AI that's been trained on the data for that pump may take an instant opinion that that pump's dead, I need to turn it off, which may isolate a huge section of your network unexpectedly and take water supply away from everybody. Because what it's being asked to look at is things that are outside of its normal operating regime. So the world of AI is brilliant when it's within the parameters. What we have to watch out for is the time that we ask it to operate outside of its parameters, because AI to a certain extent is a black box. Right? How it will respond to something that we've never asked it to respond to before is almost a complete unknown. So it's a big risk if we were to just turn around and go, brilliant, looks like AI is going to fix our lives, let's just hand over to it, off we go. There are other risks. So let's think about a water network operating in a certain way and something unusual happens within it. What we have to ask ourselves is, do we want to say, okay, AI, make your decision and implement? Or do we want to go, okay, AI, make your decision and tell us about it, and then I'll tell you what to do about it. I'll tell you whether I agree with your advice and can then implement a decision or not. Now, the speed that we move from AI gives us advice to AI makes a decision and implements, that's something that we have to be very careful about. Until we can be absolutely sure that when we're training that AI, we've covered every single circumstance that could possibly arise. And the challenge when we get to that point where we go, okay, brilliant, AI, you just go do your thing, run your network for us as good as possible. The challenge then is we start to remove humans from the loop. And if we remove a human for a loop and everything goes well for, let's say, a couple of years, and then something unusual happens, and then the AI isolates half of the network, what we've done is we've taken away the human experience. You may have somebody sat in the operating room who says, oh no, something weird's going on or whatever. But because that human then has not been asked every day to make a decision, has not been able to or asked to respond to these strange situations, what will happen over time if we allow that is that the human skill level will start to reduce. And then, when we get into an emergency situation, we're asking for people who don't have necessarily the practice or sharpened skills from having to do it every day. We're asking them to make really important decisions. So there is always a challenge of how much power, if you like, do we give AI over the control, and how much dumbing down do we want for our operators who are going to step into those really unusual decisions. So I guess if I round up, the future of AI and its influence on water could be incredible. We're talking about efficiency gains of 30, 40, 50%. We're talking about cutting wastage by 20, 30%, stuff like that. But the method that we implement AI is at least as important as the benefits it could bring. And we have to be really balanced and careful about how we do that, because we want those benefits. So we absolutely have to have those benefits. And it would be criminal not to take advantage of it. But if we do it wrong, we're just building up a whole world of hurt for later on.
Thank you, Professor Hart, and thank you for highlighting AI's limitations. I totally agree that human oversight is crucial, and I think it should be the case forever with AI. Next, we'll hear from Alya Mazrouei. She has a presentation. Alya, please go ahead.
Thank you, Noor. So, hello, everybody. As we explore, of course, how technology and AI can shape the future of water security, I'm pleased to share how the UAE, which is the UAE Research Program for Enhancement Science, is leveraging innovation, research, and collaboration to address water scarcity, one which is the most urgent challenges we face today. So, if we look at the water security from a global context, the UN predicts that nearly half of the world population will be facing high water stress by 2030. and current efforts remain insufficient to prevent severe consequences. Arid and semi-arid regions, such as the UAE, are particularly vulnerable in this case. If we look at the UAE climate specifically, with less than 100 millimeter of rainfall, high evaporation rates, low groundwater or a limited groundwater recharge, the UAE considers water security as a strategic national priority. And here where it comes the importance of addressing sustainable ways to secure water resources in this case. Looking at rainfall enhancement through the lens of weather modification, I can say. With the rising of the water stress these days, of course, in addition to the population growth and the climate change, as we know, many countries have turned to weather modification technologies such as rain enhancement. Through diversifying the water, of course, and to diversify the water resources. This science-backed approach, recognized by the UN, of course, and adopted by more than 35 nations nowadays, with the UAE among the earliest pioneers in this field, aims to augment natural rainfall amounts through airborne ground-based interventions in the microphysical processes of specific cloud types. And this is all to reduce the need of desalinated water, lowering energy use and carbon emissions, supporting grain-fed agriculture, minimizing the groundwater depletion, restoring desert ecosystems, and fostering biodiversity, providing an economically viable and environmentally friendly approach to water scarcity. And here where it comes the importance of rain enhancement. Maybe not everyone knows that the first attempt of rain enhancement or cloud seeding operations in the country here started from 82. And it was overseen by Abu Dhabi municipality at that time, followed by the commencement of cloud seeding research in 2000 in collaboration with a lot of international institutions and organizations. There was a lot, we were relying a lot on collaborations and international research collaborations here, where really pushed the boundaries in terms of this science, and during that time till 2025 or 2015 specifically, under the patronage of His Highness Sheikh Mansour bin Zayed Al Nahyan, the program, the UAE Arab, launched at the beginning of 2015, and nowadays we reach the 6th cycle where we had worked and awarded around 14 projects, with some of them focusing more into the AI and machine learning. If you go quickly looking at the rain enhancement components or the program here in the country, we'll find three main pillars in it: operations, manufacturing, and research. If we talk about the operations here are supported by a fleet of 4 specialized King Air aircraft and 5 ground generators units, and they're designed for precision ground-based cloud seeding missions. They're 24/7 in a roster, and they're always ready for any, depending on the weather conditions that is there. The most important question we've always been asked about the economical value of what we are doing, so why we're doing these cloud seeding operations. And generally speaking about that, we've done a case 2020. We looked at 390 cloud seeding operations, around 1,000 hours, and we looked at the cumulative amount or volume of rainfall amount over the country at that year, which was 5.6 billion cubic meters. When we looked at targeting only 50% of the amenable clouds, which is not the case because we always aim to target 100% of these clouds, but we took in the case 50% with a 10% enhancement of the amount of rain, and this turned out with 280 million cubic meters as a result of these cloud seeding operations, which make it very important and gives us very a high economical value out of that. The second pillar, which is the manufacturing, so here in the UAE and overseen by the National Center of Meteorology, there's the Weather Enhancement Technology Factory, which was established 2016, is manufacturing different types of flares to make sure that we're producing the seeding agents we need here in the country for our usage for the whole 12 months a year, 24/7. So we, and the most important thing is that we are also, of course, as an outcome of the research happened, that we are now exclusively manufacturing a flare, a nanomaterial flare, which gives it more efficiency than before. Coming back to the important pillar, which translates to the manufacturing and to the operations. And here where the UAE came and supported a lot of researchers, scientists around the world to find sustainable, innovative ideas to tackle the water scarcity issue here through rain enhancement and through research and innovation, breaking the boundaries, of course, in terms of the science of that. In this program, the vision is to ensure that the research translates into real-world impact by combining innovation with science, improving seeding practices, building the expertise needed to advance rainfall enhancement locally and globally. And this is the pathway to reach to our vision, which is becoming the globally recognized model for rainfall enhancement globally. Let's look at the technological infrastructure here in the country, where the program leverages here the advanced, of course, infrastructure of the National Center of Meteorology through the Atmosphere High Performance Computing System, delivering 2.8 petaflops of processing power for real-time, high-resolution simulations and AI applications. The powerful system centralizes all modeling results, their parameterization schemes, and data from all the projects we're working with, the 14 projects, including both aerial and ground-based field campaigns. And at the core of this capability is AI, which enhances cloud forecasting, identifies optimal seeding opportunities, and supports more targeted intervention strategies. Building on that, the program developed a tree-based algorithm that has significantly accelerated model performance by achieving a 67% increase in the efficiency. And in the coming slide, you can see here the cloud demonstrating the 14 projects. Out of these projects, 4 of them specifically are in the context of AI applications. One of them applied AI models to identify seedable clouds and set the groundwork for operational seeding forecasting tools. The other one developed UAV algorithms and prototypes for autonomous seeding, and later it was transferred to NCM and advanced with Khalifa University. Another project built machine learning-based nowcasting tools providing 6-hour forecasts, now being integrated with NCM's radar systems. And the 4th project is developing right now an AI decision support tool for real-time cloud seeding operations. Currently, it's undergoing with a midterm evaluation for operational adoption. And these projects are really very important to take and to accelerate the level of rain enhancement field, take it into another level where we really make sure that it's translated into a real life, and to take these operations and make sure to enhance the efficiency in a better way and a very high outcomes. And of course, this all was relying on international collaboration, multi-sector collaboration, looking into working with different sectors and taking into consideration as well supporting researchers and scientists around the world with all the facilities and funds needed. When it comes to the milestones so far, we've achieved several milestones, including hosting the first ever town hall on rain enhancement, which was why it's mentioned, because it was very important to shape the future of the field in terms of the research areas that we really target. We've been featured in the Nature magazine and received the UAE's Future Fit, and right now we are under the National Advanced Science Agenda 2031. Since the inception of the program, it was very important first to put a lot of focus on the outreach. We've reached out, and we has grown into a globally recognized model of rain enhancement through engaging with more than 1,800 researchers over 76 countries. This was, of course, with the outcome of that, we've been awarding 14 projects. These projects we're working with 208 researchers so far from 45 research institutes. And this shows how highly considerable is the international research collaboration in this program. Nowadays, of course, and with the contributions we've reached 105 published scientific articles with 10 obtained patents in this case, with more than 150 conference proceedings, specifically on rain enhancement only. And nowadays we're in the 6th cycle, waiting for more and more of innovative ideas to start working with them in a new research journey with the coming years. And we'll be announcing the new awarded projects next January, inshallah. Of course, the very important thing that we are always relying or scoring that based on their alignment with the program's core research areas, the scientific excellence, potential impact and expertise of proposers, and the extent of multidisciplinary collaboration, as we really focus on that very high. We do support the scientists. We make sure that we're always giving them a continuous technical and logistical and advisory support through NCM R&D. And we also make sure that we monitor the progress and we face the challenges together in a joint team with them. The 5 focus areas which are very important we're looking at, and of course the main of those are the advanced models, software and data. So we are focusing on the optimized seeding materials, focusing on the novel cloud formation systems, UAVs, limited area climate interventions, and as I mentioned, advanced models, software and data. But as we can see, since the inception of the UAE Arab, we've been supporting the advancement of new hybrid AI, physics-based modeling tools, software development and deployment for the application. In fact, the advanced models and software and data is the core of our 5 strategic area. And we always look toward working closely with the projects with NCM to take the TRLs into a very high TRL from 4, for example, with a project, starting the project, reaching to a TRL of 9 to make sure that it goes into it translated into operations in a very effective way. And finally, with looking ahead 2030, the strategic goals that we are looking at is to accelerate innovation through AI-based cloud seeding or cloud forecasting and autonomous aerial systems. We also look to support high-risk, high-reward research through to scale rain enhancement, and we are looking to strengthen the global leadership through collaboration with multi-sectors, of course, academia, industry, and policymakers, merging the government with the public and with the private, and making sure to have this sort of collaboration or multi-sector collaboration in a higher basis. And we also look to promote knowledge exchange, technology transfer, and of course the capacity building is very also important, and to integrate rain enhancement into water resource management to support vulnerable communities. Thank you very much. Hopefully, I'm here around for any connection regarding this topic. Thank you so much.
Thank you, Alya, for sharing your perspective. Now I'd like to invite Professor Hosni to share his remarks.
Thank you, Noor. So this water and water security and AI is one of the topic of interest, especially for me. With my PhD in water science, I have been with Masdar for more than 10 years in renewable energy, and now with Mazrouei for more than 5 years in AI field. So for me, mixing water, energy, and AI is part of my DNA, and I'd be happy to share my vision, my experience about this field. So when we talk about water security, especially here in the region, so we cannot dissociate from energy, because here water is energy. 95% of our drinking water is coming from desalination, with all the challenges, as Dr. Saeed mentioned in his intervention about environmental impact, about optimization of the desalination process. So when we talk about water, we cannot dissociate from energy, because here 1 liter of water can be converted to kilowatt hour, because we need energy to desalinate water, and saving water is saving energy, and water security is related to energy security as well. So it's very important to take from that angle and see how innovation and technology can contribute to improve the efficiency from the energy side and also from the water production side. So it was mentioned earlier that now the direction of desalination technology is shifting more to reverse osmosis, but in the UAE we still have very strong and big percentage of cogeneration in our desalination water production, and cogeneration produce electricity, and then the water is the byproduct of electricity. And sometimes, especially during summer, when we have very high demand on electricity for cooling and to support all the industrial ecosystem, so we have more production of water than what we need, and how this water can be used and can be saved, can be stored in a way can contribute to the water security of the country. And there are many flagship initiatives where the excess of water resource produced from desalination is used to refill some of protected and well-designed aquifers to be used as storage, like in Liwa or in some area where can be used for our water security. This is from UAE and GCC angle, where it's very specific water security concern, especially when your water is coming 100% almost from desalination. But if we take it from a large scale, let's say from the MENA region, so MENA is completely different. So there are very high scarcity countries as well, but not like 100 millimeter precipitation, but where we have different climate in the Mediterranean side. In the Gulf region, we have completely different climate where almost no surface water. The precipitation also is getting very scarce in terms of time and space distribution. It's where I think geoengineering and rain enhancement of one of the program where AI can play a role as well. As Alya mentioned about UAE Arab program, it's more and more focused in the recent and the previous call about AI, because AI is very important in terms of improving the efficiency, optimizing operation, taking advantage of all possible information that can help operator at NCM to optimize the seeding operation. Here we're talking about terabyte of data collected from different sources, from Doppler radar, from satellite data, from very heavy atmospheric model that give you location and time of cloud with potential seedability, and how AI can help to improve. Even 5% improvement in the seedability estimation of those clouds can have impact in terms of amount of water can be generated from desalination. So it's why now bringing AI expert, bringing water source expert, bringing people from different backgrounds that they speak different languages, talk together and see how we can leverage on this technology to improve the efficiency of those operations. Also, I am involved in another project that's also funded by UAE leadership on AI for Water initiative. And yesterday, one of the panel, Aisha, has presented this initiative of Mohamed bin Zayed Water Initiative, supporting many initiatives globally, mainly in Africa, and how AI can help in the water resource management in different countries. And we're starting with a big water basin in South Africa, covering 5 countries, collecting data from hydrological model, and also integrating AI for our weather forecasting model. And NCM will have very important workshop next week on bringing all the experts globally to see how AI can help in the weather prediction. But when we talk about weather prediction, we are also talking about precipitation, and precipitation is about the water because it's the main input for any water security system. And this is how AI can help in the estimation and the prediction of precipitation, not just for the weather forecast, but also season to season, season to sub-season, to be able to tell how much rain we expect next season. And the farmers can take decision about what crops they can choose based on those predictions. And AI is making now a huge revolution in terms of weather forecast. And if you see what's going on with Google, with Deepcast, with GraphCast, that are able to predict precipitation with better accuracy compared to the usual like atmospheric model. And we tested recently with the flooding that happened in the UAE, especially in Dubai in 2024, and we find out that with AI we're able to forecast the amount of rain that exceeding all data used in training, because those models are trained with 50 years of data, and the rain that were observed in the UAE last year was not recorded like for more than 250, estimated that more than that happened once in each 250 years, and this is why AI is getting more and more attention, especially now. It's very usual to have some resistance from traditional way to predict and forecast weather, especially precipitation, but now with the number we're getting, with the accuracy we're getting, with AI-based forecast, it's changing completely the game of weather forecast, especially in the computing needs, because some country, they don't have resources to be able to have this accurate atmospheric model forecast. But now with AI, with a simple laptop, you can produce those forecasts with very acceptable accuracy. And this is the point where AI can help in the water security, especially here, as Dr. Philip mentioned, especially in the predictive maintenance as well, since we are talking here back to desalination technology, how AI can help to be able to monitor the operation, to develop like this digital twins, that is a mix of data fusion, that you can use for reverse engineering to be able to simulate different scenarios. Let's say if the salinity in the Gulf would be increasing by 10%, and we can see the trend that salinity is increasing, not because of the brine, but also because of many other geological and also geopolitical factors in the region, where most of dams were built in the Euphrates River, so there is no fresh water coming to the Arabian Gulf, and also more activity, as also the increase of the temperature. It's increasing evaporation, and the inflow from the Arabian Sea is getting less and less. We have very more increasing retention time of the water in the Gulf that is impacting salinity. So how you can run the whole desalination ecosystem in the UAE and other Gulf region to be able to say, this is the impact of salinity on our operational desalination. And this is also very impactful because the amount of energy needed to desalinate is somehow correlated to the salinity of the water. And also the amount of the brine that, as Professor Saeed mentioned in his talk, the brine produced and discharged in the Gulf, how will be in the long run impacting the whole system. And this is where the AI community can play a role in this, in infusing data from different sources, in bringing different parameters in terms of time and space, and be able to simulate this scenario. And we are working project on developing a digital twin of the Arabian Gulf. And desalination is one big component in it. And also the fish stock is one component, because we cannot talk about water energy nexus and water security and energy security without talking about food security as well. It's part of the whole chain, because people, when I joined Mazrouei in 2009, people are asking why UAE, like oil-rich country, investing in renewable energy. But the vision of the leadership at that time is since we have oil, so we can invest and to be in the front run in technology, in desalination, in energy production, is to be able to close the loop after oil. So when you have sun, you can produce energy. When you have energy, you can produce water. When you have water, you can produce food, and you can close the loop in the system without oil. And this is the vision of the leadership, where they start investing in renewable energy. At that time, the kilowatt hour cost 30 cents. Now is about 1 cent. And this is a huge difference in this. So now to go back to the question of AI, it's very important, especially when we talk about AI, we talk about data. When we talk about water resource and water security, also it's a huge volume of data that is needed to be treated, to be assimilated in near real time, to be able to have a decision that can help policymaker, decision maker take action on the spot. And this is where the AI community, from the machine learning, for the deep learning, can have this contribution to this ecosystem. And I'm happy to discuss with you any more details about this project and how AI can help in this effort for the water security and energy security in the country and also globally. Thank you, Noor.
Thank you, Professor. We're grateful for your contribution. We'll save our questions to the end of the panel, hopefully. Dr. Khalid Al-Ghafli, we're eager to hear your views.
Sure. So during the Water World Day in 2024, the theme was Water for Peace. So they have discussed interesting facts about that more than 3 billion people rely on water that crosses boundary. So we're talking about transboundary basins and catchments. So how about the aquifers? The aquifers are invisible. We cannot see the aquifers. To monitor the aquifers, we need telemetric monitoring wells. So back in the days, if you talk about 5 or 6 decades ago, people started to introduce the drilling technologies, where they started to dig deeper wells. Before they used to have hand-dug wells or relying on surface waters. So these technologies supported many people. At the same time, the groundwater level was declining. Groundwater, in fact, you're talking about more than 80% of fresh water, if we exclude glaciers, are groundwater. The rest are surface water and rivers. So people then start to introduce new regulations and new policies to preserve the groundwater resources, since people are competing and drilling deeper wells to reach the groundwater resources. Then people start to introduce also telemetric monitoring wells. And those wells, the target of those wells are to monitor the groundwater levels and make sure it's not dropping or declining more than a specific amount, for example. Then we have GRACE missions, GRACE satellites. It was introduced in 2002. And from 2002 until now, we only have this satellite as the only satellite that we can monitor the groundwater resources. But at the same time, we have now data from other remote sensing data, satellite data, with the AI, digital twins, as you have mentioned. We can replicate the physical behavior of the groundwater resources. Back in the days, or even until today, many government sectors, they use numerical simulations. And these simulations are to simulate the groundwater behaviors, but it's in a steady state or in a transient state. But you have to keep update the system. This is where digital twins is introduced as a system that keeps feeding the information in the model. You have model, you have live data, and you have the AI. So both are working and functioning together, so we have live monitoring for groundwater resources, for example. So this could help us to look at different policies, different strategies, managements. Before we introduce these management and policies, we could assess these in the models. Then we have, can you imagine now we're talking only about groundwater resources. How about if we introduce digital twins and couple it with urban drainage systems? You couple it also with the flood early warning systems, You could also couple it with desalination plants, operations, the water prices, and you have also the wastewater plants. All this together will come, and now we could introduce the water governance and integrated water resources management. Many government sectors nowadays, they start to customize their own platforms instead of relying on the traditional models, because customized softwares, nowadays we have different scenarios, different issues for each country. So we cannot generalize one software that could be scaled up to everywhere. So yeah, this is what I have for now. Thank you.
Thank you, Dr. Khalid, for rounding out our discussions on such a valuable note. We'll now move to the Q&A portion of the session. I do have a few questions for our panelists. The first question is for Ms. Alya. I'm interested to hear your perspective as a director. How have international collaborations shaped the role of the UAE's rain enhancement program in water security efforts on a global scale?
Of course, this is really a vital factor for that. It's a very important one, and we rely on it and we take it into a very high we consider it very high in the program. Through the program, we do believe that rain enhancement must be viewed as a science-based contributor to the water security, and this is alongside with the existing water resources. So, especially in our region, where it's or any arid and semi-arid regions, again, we do believe that the problem or the issue or the challenge that we're going through is also there in a lot of other countries, and they all need, and there are some even countries they need the support in terms of how to rely on other water resources. And in this case, we always make sure to through the collaboration and through working with others and looking at working with other countries as well, we're making sure to cover the knowledge transfer, to make sure that the technology transfer as well is done in a proper way. And during the last couple of years, the network of stakeholders or the network we built through this collaboration helped a lot in this case. In addition to that, it helps us a lot in turning our technology readiness level of every single project from 4, for example, to 9. So when we take it and we push it to commercialization, it's very important to do this with working with other sectors, not a specific sector. There are some facilities and some needs, depending on the research components, where you need some sectors than other. And this was very important for us. It helped a lot when it comes to collaboration. So we take it as a number one pillar, actually, in this type of programs.
Thank you for sharing your perspective. We have time for one more question, which I'd like to ask Dr. Khalid. Would you say that the solution to water scarcity issues is more about innovation or other factors like governance and decision making?
Well, I published one paper a year ago, and it was about predicting the groundwater level change using satellites, and I compared the data with the observation data in UAE. As I'm looking at the groundwater decline, the groundwater level decline, I see it was in a sharp decline until 2009. Then it started to stabilize. I asked many people about why the groundwater started to stabilize, and the rainfall data that I have are not showing the response of the aquifers after this decline. So it stabilized because after asking a team member from ADAFSA, they introduced a new policy to subsidize the farms. At the same time, you reduce growing certain crops, for example, alfalfa hay, since it consumes a big amount of water, large amount of water. So this was as a policy solutions. So usually we need an integrated water resource management techniques applied, where all the stakeholders are sitting together and discuss, which means also we're talking about an interdisciplinary techniques. And this is where the majority of universities nowadays, they open new colleges where you have social scientists, engineers, people from different disciplines, economists, all of them, they're sitting together and working on one topic, for example.
Yes. Thank you, Dr. Khalid. This concludes our 5th panel. We appreciate the audience for your engagement and our panelists for sharing their knowledge. Please join me in giving them a round of applause and enjoy the rest of the conference.